Hello everyone, thank you for coming to the channel again, and I hope the content I keep on sharing is helping you. I really hope that. Today I'm going to focus on the geometric or the exponential sequence. Are we together? The geometric sequence. The general term, the general formula that can give you all the terms of the geometric or the the exponential sequence is given by Tn is equal to a multiplied by r to the n minus 1. Alright, together. Where a is your first term of the sequence, r is the common ratio, and then n, same thing applies here as it did in arithmetic sequence. N can give you two things. It can give you the position of a term, or the position of a term or the number of terms. Are we together? So firstly, whenever they say to you a particular sequence is geometric or it is exponential, the first thing that should come into your mind is that it has a constant ratio. And how do you get a constant ratio? It's the quotient of two terms, t2 over t1 is the same as t3 over t2, same as t4 over t3. This thing will go until the last term of the sequence, tn all over tn minus 1. All right, together. So the whenever they say to you the sequence is geometric, this thing should be the first one that clicks into your mind, that it has a common ratio. All right, together. Okay, now let's start to analyze our general term. Our general term has three unknowns. It has the value of a, which is the first term of the sequence, r, the common ratio of the sequence, and then n. N tells us about two things: the position or the number of terms. All right, together. So let's focus on n a bit. N, for n to give you a position of a term, a position of a term, you must be given the value of that particular term. For you to find the position of a term, you must be given the value of that term. Are we together? But if you want to focus on n and you want to get the number of terms, the total number of terms in the sequence, you must be given the last term. The last term of the sequence. right together. So in this case, in this example, I want us to focus on a simple example whereby we have a quadratic, a geometric number pattern rather. A geometric number pattern. Let's say we have a sequence like this. We have 2, 4, 8. This thing, let's say it goes until 1000. Say this thing goes until 1024, and then you have questions to answer. Number one. Question number one, maybe let's say it says find the fourth term, T4. Find T4. How can you do that? Already we do have our sequence here. Our sequence is 2, 4, and 8. It goes until 1024. I said to you, for a geometric sequence or an exponential sequence, we have a common ratio. How do we get a common ratio? We'll say T2 over T1, that will be 4 over 2, we'll get a 2. 8 over 4, we'll get a 2. That means our ratio is 2. For us to find the next terms in a geometric sequence or number pattern, you must just multiply the term that you have with the common ratio. For example, my first term was 2. If I multiply 2 by the common ratio, I'll get 4. If I multiply 4 by the common ratio, I'll get 8. That thing simply means T4 will be equal to 16 altogether. Question number 2. Find the nth term. The nth term Tn of the sequence. Since you are dealing with geometric sequence, there are only two things you need to find Tn. It's only A and R, whereby A is your first term and R is your common ratio. All together. In this case, our first term is given as 2 and R is also 2. So go like 2 and 2. So when we write, it will be like 2. This will be Tn. Always the time, your nth term should be in terms of n. Always the time. And then now let's deal with n. For you to find the position of a term, they'll be like which term of the sequence is equal to 128. They have given us the term, which is 128. All we need to do is to find where is 128 on our sequence, the position of 128. How can we do that? We know that a Tn is A R minus 1. Our term is 128 and we want the position of term number 128 on the sequence. Our A is 2, our R is also 2, n minus 1. Here you're just supposed to solve for n, and n is like the exponent. So the first thing you must do, you must remove everything and leave the base with an unknown exponent on one side. Everything should be on the other side. So here the first thing you must do is to divide by 2 like this, and then we will have 64. This is 2 to the power n minus 1. 64 can be written as 2 to the power 6 This is 2 to the power n minus 1. When the bases are the same, that means exponents are equal. So n is equal to 7. This thing simply means that the 7th term is the 1, which is equal to 128. Can you see that, guys? Whenever they want you to find the position of a term, they must give you the term itself, and then you'll go and calculate n, like this. Are you together? Okay, and then now let's say now they want us to find the number of terms. Number 4, calculate the number of terms in the sequence. For us to find the number of terms, we must know the value of the last term. In this case is 1024. Our first term is 2, our r is 2, we don't know n. Go back to our formula. It's 1024, 2, we have 2 and n minus 1 here. Same thing applies. You're solving for n is at the exponent. Must divide both sides by 2. 1024 divided by 2 is 512. It's 512 can be 2, 4, 6, 2, 4, 8, 16, 32, 64, 128, 2, 5, 6, 5, 12. This thing is 2 to the power 9. So whenever the bases are the same, that means the exponents are equal. So n is equal to 10. To answer the question, therefore, there are 10 terms in the sequence. Are you together? So by just doing these simple questions, the grade 11 content is done. Basically, grade 10 and 11. All that I'm left with now is to do the grade 12 parts, whereby I must calculate the sum of the terms. Are you together? Okay. At some point, you must add the sum of the terms of a geometric or an exponential sequence. Are you together? And there is a formula for that. The formula says Sn is equal to a r to the power n minus 1 all over r, or you can use this one, 1 minus r to the power n, and then like this. We use this one whenever r is greater than 1, and we use this one whenever r is less than 1. Are you together? But in both of them, please note, let me write this part in red. R can never be 1, because when r is equal to 1, our denominator will be undefined. Not our denominator, the entire thing will be undefined, because our denominator is 0. Are you together? So yeah, this is how you calculate the sum of the first n terms given a particular sequence. Whether that sequence is increasing or decreasing, it doesn't make sense. Yeah, not that doesn't make sense, it doesn't matter rather. Are you together? Sometimes you'll be asked to find a sum to infinity. Okay. Whenever you're dealing with sum to infinity, please note that you only calculate a sum to infinity when our sequence converges. Are you together? When our sequence converges, it simply means that our common ratio is between -1 and 1. Are you together? And for a sequence to converge, it simply means that as as you go on counting the sum of the terms of the sequence, as you keep on going on, like the value does not change. It converges to a specific number, because you keep on adding smaller numbers that necessarily don't have an effect on the sum. Are we together? So that's why we say that sometimes a geometric sequence converges, and the only geometric sequence that converges is the one that has a ratio which is between minus 1 and 1. Are we together? So for example, let's take another example. Let's say now we have 16, we have 4, we have 1, etc. And then the first question will be like, find the next 3 terms of the geometric series or sequence. Then number 2, determine the nth term of the sequence. You can pause the video and do these questions on your own, and then we'll do it together. That question will be like, which term of the sequence is equal to 1/32, not 1/32, 1/64. Number 4, calculate n, let me write it in black, n the number of terms if the last term is 1/1024. And then number 5, calculate the sum of the first n terms. Then number 6, calculate the sum to infinity. Or before they say calculate the sum to infinity, they'll ask you a question. Is this a convergent geometric sequence? Number 7. Calculate sum. Calculate sum to infinity. Okay. Let's go, guys. Number 1. Let me write in black. My sequence was 16, 14, and 1, and I'm supposed to find the next 3 terms: 16, 4, and 1. So my common ratio, 4 divided by 16, I know it will give me 1 over 4, 1 over 4. So for me to find the next term, I must just multiply the previous term with 1 over 4. 1 multiplied by 1 over 4 is 1 over 4. 1 over 16, and then 1 over 64. So these are the next 3 terms: 1, 2, and 3. Add it together. Just multiply them by the ratio. Number 2, find the nth term, Tn. There are only 2 things you need to find the nth term. Now, you only need the first term and the common ratio. So our first term is 16. Our ratio is 1 over 4. So our Tn will be what? 16 multiplied by 1 over 4, all raised to the power n. Number 3, I must calculate, what's the question saying? Which term of the sequence is equal to 1 over 64? I already know that that's going to be the 6th term. Né? Let's say I calculated incorrectly on number 1. I'm simply going to say Tn is A Okay, I know that I want term number 1 over 64. I want to know in which position is that term. I already know that term 164 is term number 6. My A is 16. Okay. 164, I can write it as 1 over 4 to the cube, 1 over 4 to the power 3, all over 1 This thing is 4 cubed multiplied by 1 over 4 n minus 1. I'm solving n, and I must always isolate the base with an unknown exponent. Excuse, I made a mistake. The 16 is 4 squared. Né? That means I have to divide both sides by 4 squared, because I want to isolate the base with an unknown exponent. This will cancel this. I'll be left with a 1 over 4 squared multiplied by 1 over 4 cubed. The bases are the same. I can just add the exponents. 1 over 4 n minus 1. And then this thing can be written as 1 over 4 all to the power 5, 1 over 4 n minus 1. Since my bases are the same, that means my exponent should be equal. Therefore, n is 6. This thing supports our statement that yes, the 6th term is this one. All right, together. Then question number 4 rather, they want us to find n, the last term. they want us to find the number of terms in the sequence if this guy is the last term. I'm given, okay, let me write down my data. I'm given the last term, which is 1 over 1024. I know that A 16, R is 1 over 4. I want to know how many terms are in the sequence if this guy is the last term. So I'll be like Tn is equal to A R minus 1. Guys, if you're struggling with knowing how to answer these exponential equations, please don't be shy. Lesson number 6 on algebra, I'm doing exponents there. You'll learn the basic on how to answer on how to solve for exponential equations. A is 16. This is 1 over 4. Let me check. 4, 16, 64, 256, 5, 256. Okay, this thing is the same as 1 to the power 4, 1 over 4 to the power 5. This thing is 4 squared. Here I have 1 over 4 n minus 1. So I want to remove 4 squared. That means I must divide both sides by 4 squared. 4 squared, 4 squared. This will cancel this, and then on the left hand side I'll be left with 1 over, I'm multiplying bases that are the same. I must just add the exponents. So this thing can be written as 1 over 4 all raised to the power 7 is equal to 1 over 4. Now I have my bases to be the same. That means my exponents should be equal. That means if this guy is my last term, it simply means I have 8 terms in the sequence. Right, together. And then number 5, I'm supposed to find the sum of the first n terms. The sum of the first n terms. N is what I just calculated, the last term. So I want to find sum of the I'm choosing this one because my r is less than 1, yeah? So sum of the first n terms, A is 16, 1 over 4 power 8, 1 minus 1 over 4. Actually, I don't have a calculator, but I'll have 64. Mm, 4 minus 1 is 3 here. 64 is 4 cubed. Guys, when you are here, just punch your calculator. Ne? I don't have one, so I'm trying to do this thing without a calculator. This is 4 to the power minus 8 all over 3. This is 4 cubed minus 4 to the power minus 5 over 3. this is 64 1024 over 3. Hey, now just punch a calculator, I'll get big numbers here. I try to be fancy, guys, but more figure, just punch your calculator. Even my mother tongue is Kiki, should be. When you arrive here, just punch your calculator, you'll find your answer. Right, together. And now let's move. The sixth question, they asked us, is this a converging geometric sequence, yes or no? For it to converge, that means R should be between -1 and 1. Please remember that, ne? Okay, let's find R. R is equal to T2 over T1. T2 is 4, T1 is 16. That means it's 1 over 4. So when you answer, will say yes, it is a geometric series. Why? Because R, which is equal to 1 over 4, is a number that is between -1 and 1. Please, guys, the reason is so important. Are we together? Now, since our sequence is converging, we can calculate sum to infinity. We can simply say that sum to infinity is equal to A1 minus R. Our value of A is 16. Our R is 1 over 4. This thing will give us 64 over 3. Then you find your answer. Right, together. So this thing simply means that this sequence converges to this number. Right, together. And then maybe the 8th question was going to say, represent the sequence in sigma notation. I'll do it in 2 ways because we did calculate the sum to infinity as well. The one that did not have a sum to infinity, you can say n and then put 8 there. 16 1 over 4 to the power n is equal to, if we calculated let's say this guy here, since we did find the sum of the first 8 terms, let's say it's equal to x. I don't know the value. We'll just say this thing, when you add the numbers from first term until the 8th term, you'll get x. Simple as that. And then for if you want to represent it as sum to infinity, you can say n is 1, put infinity there, put 16 1 over 4, and then this thing will be what? 64 over 3. Right, together. This is how you represent your sum in sigma notation. Okay, and then we'll be asked to sometimes the sequence will never be given to you, however it will be described to you. When it is described, the same thing we did with arithmetic sequence, we're going to use this guy, our general term. We know that this thing will give us all the terms of a geometric sequence. If you want T1, that means whenever we see n, we must substitute 1. We'll have 1 minus 1, and we'll have the exponent of 0. So r to the power 0 is just 1. So T1 is equal to A. T2, whenever we see r, we put 2 there. So we'll have AR. T3, whenever we see n, we put 3. So we'll have AR squared. Alright, together. For T4, whenever we see n, we put 4 there. We have AR to the power 3. The trend just keep on going like this, guys. The position of a term is 1 unit more than the exponent here. Right, together. So T10, I'm expecting it to be AR to the power 9. T15, I'm expecting it to be AR to the power 14. T20, I'm expecting it to be to be like this. Then T100, it will be AR to the power 99. Alright, together. So we use these things whenever a sequence is described to us. Let me find an example when a sequence is described. When a sequence is described, how can we go with it? Okay, yeah. Here's the example. Please write it down as well. If I want to write something like this, the quotient of the fifth and the third term of a geometric sequence is 4. And then we are told that second statement, the fourth term is 24. Then the question goes like, determine the sum of the first 7 terms. Okay, here's a statement, guys. I'm told that the quotient of T3 and of T5 and T3 is 4. Whenever I divide term 5 with T3, I'll get 4. And I'm also told that the fourth term is 24. They want me to find the sum of the first 7 terms. For me to find the sum, I need the value of A, N, and R. I know N is 7, but I must find A and R. How can I do so? There is an information that I'm given here. I'm told that whenever I divide the fifth term and the fourth term and the third term rather, I'll get 4. And the fifth term and the third term I'll get 4. For me, whenever I want the fifth term, it's simple. I must say AR to the power 4 all over AR to the power 2. This thing is equal to 4. All together. So I know that these things will cancel since we are dividing together. R and R, we are dividing bases that are the same. So it will be R to the power 4 minus 2 is equal to 4. Then R squared is 4. Then I'll just put a square root both sides. R is plus or minus 2. Like this. Together. In this question, the setting that they didn't specify whether 2 is greater than 0 or not, but it's fine. We will deal with R as positive 2 and negative 2. Then we must go and find A. We were told that T4 is equal to 24. Together, this thing simply means that AR to the 3 is 24. So when R is 2 and when R is negative 2, how can we solve? We want A. Just put 2 there, 24, and then A will be equal to 24 over 2 cubed, 24. It will give us a positive 3. Together. Then whenever we put a negative 2, A will be equal to a negative 3. So for us to find the sum of the first 7 terms, it's either our sequence will look like this: 3, Since r is 2, we'll get 6 here, 12, etc. Or 6, 12, and 24. And then when r is negative 3, when r is negative 2, simply means our a is negative 3, right? Is negative 3. That means my second term will be what? A positive 6. Then I'll have a negative 12. Then I'll have a positive 24 as well. Why? Because my r is negative 2. Here my r was 2. For me to find the next term, I must just keep on multiplying by the common ratio. So the sum of the first 7 terms, r minus 1, a is 3, 2 to the power 7, 2 minus 1. So my answer is 3 times 2 to the power 7 is 128 minus 1. 128 times 3, 24, 6, 8. I'll get 384. Whenever my r is positive 2, but whenever my r is not positive 2, what will I get? Sum of the first 7 terms. My a here is negative 3, 1 minus my r is negative 2 to the power 7, 1 minus negative 2. So I'll have negative 3, 1 plus 128 all over 3. So this will cancel this, then I'll have negative 129. So when my sequence is 3, 6, 12, and 24, the sum of the first 7 terms becomes this guy. But whenever my sequence is negative 3, 6, negative 12, and 24, the sum of the first 7 terms become this one. I hope you guys will understand, and please stay tuned for more, where I will tackle more questions regarding the geometric sequence and how to deal with any type of a question, by the way. Just stay tuned, like, subscribe, watch more videos, guys, especially the algebra videos. They are more helpful because whenever I deal with sequence, only the first 2 steps are just sequences and series, and then the rest is just algebra. Please, guys, I'd rather understand algebra more than anything for me to pass maths. Thank you.